Hello, friends. I am going to talk about this Karnaugh mapping simplification methods. Karnaugh mapping or K mapping. This question will demonstrate presentation will demonstrate how to create and level 2, 3 and 4 variables K maps. Use the K mapping techniques to simplify logic designs with 2, 3 and 4 variables. Use the K mapping techniques to simplify logic design containing don't care conditions. K-map techniques are graphical techniques used to simplify logic expression. K-maps are procedural and much cleaner than Boolean simplification. K-maps can be used for any number of input variables but are only practical for 2, 3 or 4 variables. K-map format. In each format, truth table corresponds to a cell in a K-map. K-map cells are labeled such that both horizontal and vertical movements differ only by one variable. Since the adjacent cells differ by only one variable, they can be grouped to create simpler terms in sum of product expression. Sum of product expression for the logic function can be obtained by ORing together the cells of group of cells. It is evident from here. If we group this 1 and 1, say before grouping we get two functions of two variables wx bar and wx bar. If we make pair, then x bar is common and w adjacent this variable opposite is reduced and we get only x bar. Truth table to K-map mapping. Two variable K-maps. Here actually this min term numbers 0, 1, 2, 3 and corresponding positions in K-map are this 0, 1, 2 and 3 and we have to make entries according to these positions from truth table. Now if there are 4 ones, if you don't make groups, only group of ones, then 4 groups will be and all min terms will be there involved, 4. If you make group of 2s, that is pair, then we can see for this first pair, A is reduced, we get only B bar, and this pair, this A is again reduced and we get only B. For a pair, two variables are reduced, so all A and B both are reduced and only one is available. K simplification process. Construction and process, after this there are certain points are there. You can take a pause and read this. So I go to another slides. Two variable maps, this is it, example is here. So if these are input J and K and F1 is output, then respective positions are this and this, we get this, one pair is possible, we make pair. So here only we get J bar as the output, K is reduced. If we consider three variable K-map, then for this will be the format of K-map. Positions of midterms 0 to 7 will be here, respect to 0, 1, 2, 3, 4, 5 below and then 6, 7. And accordingly these output ones will be entered. And we can make all the groups, so 2, 4 or even 8. You can see here, we can make group of 4s. So in group of 4s, two variables are reduced and only one variable is remaining like A bar, B and E. If you make group of 8 here for three variable K-map, then all ones are there, group of 8, then all three variables are reduced and only one is remaining. Here we can have, see in one example, this is a truth table. We can fill up here respect to entries from here. It is filled up here and now we make and try to make pairs. There is one pair, this one and this one. And second pair is side two ones, this and this. So for this pair we get F bar G and this for FG bar. This is written here, file expression. We can make them from here circuits, digital circuits. We can also apply this K-map techniques to 4 variables. Now this is the format. All these are 16 midterms, 0 to 15 are positioned here from 0, 1 to 3 and like this up to 10. So you have to fill up this respect to entries. For this example, we can consider, we can make the group of fours, that is quads. So one quad is this, with this, so we get B bar, and this we get only D bar. So that will be the final our result. If all are 1, we can also make a group of 16. So for in this, all 4 variables are reduced. And here 4 variables. Don't care condition we can assume. Don't care conditions. Don't care we treat 1 or 0. This can be treated as 1 or 0. So here you can see some group for don't care. If this is don't care, we can treat it as 1 to make the pair, and we can reduce the variable. In the same way, we can, if we take example of 4 variables here, entry after entry, we can make pair by assuming these two, considering these two as don't care condition, taking it as 1. So one quad is possible here and one quad is here. In this way, R by T and R by 2, we can get this reduced is 1 is this. So in this way, we can simplify and reduce the functions. Final functions are this, and we can make accordingly digital circuits. Okay, then thanks.